Greetings YouTube. Today I'm going to review the latest non-fiction book I have read. In fact, I finished it this morning at around 4:45 a.m. It is the Whole Shebang, a State of the Universes report by Timothy Ferris. This is a book that deals with quantum mechanics and cosmology. Timothy Ferris is a cosmologist, a person that studies really large structures out there in our universe. Things beyond the star stage, things like galaxies and clusters of galaxies and superclusters of galaxies and walls, which are clusters of superclusters. So big structures. So it's a book that, it's a pretty hefty sized book, though the section of notes in the back is fairly extensive. It's like a good 30 or 40 pages of notes. So it covers a wide series of topics, talks about a whole lot of researchers. I was quite pleased to see that it did cover quite a few female researchers. There is such a dearth of coverage for female researchers, even in the best of science books. It always kind of distresses me. But it also covers the full range of the research that has led us to a modern view of cosmology, starting with Copernicus and Galileo and moving forward to the most up-to-date information. I think this was written near the end of the last century. So there is more available, more up-to-date information available out there, but this is a very good book. Now, they did introduce a few things to me that I wasn't aware of, and some of them are light. For example, Einstein preferred to refer to his theory of special relativity as the invariance theory, and I think that would have given a much different take to the world at large if they had originally been presented the theory as the invariance theory, because the speed of light is it does not vary regardless of the point of view of the observer, as opposed to the special theory of relativity, which has a much more vague, wishy-washy sound, which I think confuses some people. Though the author does use the as you go faster and faster, you gain more mass. Now, that does make sense because mass and energy are equal to each other. However, it is a meme that has never clicked with me, ever. It just doesn't make sense in my head. I much prefer Brian Greene's take on it, where he says that everything moves at the speed of light. He says that most of our energy is taken up with us moving through time. And as we increase our forward speed, acceleration, we have less and less energy available for moving through time, till eventually, when you get to the speed of light itself, time stops, which is why you can't go faster than the speed of light, which I think is a much better meme concept to me. He also talks about inflation. Now, I've heard of inflation theory as an explanation about why the universe is the size it is, in particular, why the four dimensions that we are used to percolated out of the higher dimensions that are required by Superstring Theory. But I always worked under the assumption that there had been a single inflation event. And that single inflation event pretty much gave us the world, the universe that we see around us. Now, we live in a bubble known as the observable universe. And this is the area that we can see from where we are. It is not the entirety of the universe. The universe is roughly 15 billion years old, so that means that our bubble of the observable universe is about 30 billion light years in diameter. It's a really big space. We have lots to work with for a long time to come. But I always assumed, from things I'd read in the past, that was like 70 or more % of the known universe. It was a little bit bigger than that, but that was the bulk of it. Well, it appears that there may have been as many as 90 inflation events. And each of these inflation events doubled the size of the universe. So we'll imagine that the first inflation event brought us to a 30 billion light year bubble. The second one took us to 60, 120, 240, 480, 960. You can see where this is going. If it hits 90 times that this happens, you're talking very quickly hitting numbers in the sextillion range of light years. The universe is a dizzying concept, and this book did a very good job of conveying that to me. It is, in the most true definition of the word, awesome. It also touched on superstring theory being as an explanation to explain the difference between local and non-local events. Now, local event. I hit the table shakes, camera shakes, there's a connection. That is a local event. It is what we are used to. Our, mechanical view of our universe, our Newtonian physics that we are used to in the day-to-day life, makes us think everything is a local event. But when you start getting into the quantum mechanics, you discover that there are non-local events, that particles can be a light year apart, more, and then one of them is examined and suddenly the other's state changes. Because you examined into one particle over here, this particle changes, even though they're going to be a light year apart. And that non-local event really disturbs a lot of researchers, including Einstein, who called it spooky action at a distance. And it is spooky action at a distance. However, if superstring theory can be proven correct, it is a very likely possibility that there are no such things as local events, or no such thing as non-local events, depending on how you want to look at it, that everything is all connected. Yes, that's very Taoist. But the reality is that those two particles, even though they're a light year apart, are the same particle. They are connected on the superstring subatomic quantum level in a way that we cannot easily perceive from our ordinary, everyday Newtonian view of the world. And that's cool. Now, to me, one of the signs of a good book is if I don't want the book to end. And I didn't want this book to end. It was just a lot of fun. I wanted Timothy Ferris to just keep explaining stuff to me. So I'm going to hunt down some of his other books, I think, because he is an excellent writer. It was a great read. Yes, it isn't an easy read, but there's very little math. He saves the math for the notes, so you don't have to worry about having to tackle a whole lot of formulas and things like that. There's a few illustrations he uses to explain some particularly sticky points, but for the most part, everything can be described by him in words, and you will have a great understanding of what he's discussing. So, very much high recommendation for me on this book. It was a great read. I had a good time. Go get a copy.